Today we're going to start our next unit, and in Unit 6 we're going to start with perpendicular and angle bisectors. One thing to remember from our past is bisector. Remember that means to bisect, chop in half. The next piece is equidistant, so it's another vocab word that we can kind of take a look at. And the equidistant means that the points are going to be the same distance from whatever figure it is that we're talking about. So when they say equidistant, that's what it means. And you can kind of see the word equal distance. It's almost kind of built in to the word itself. So this here is kind of an illustration of what we're talking about. So this line CP, so that's this guy right here, line CP, is a perpendicular, remember perpendicular is that upside down T, bisector of line segment AB. So I have line segment AB. This line is a perpendicular bisector. It's perpendicular because I can see this 90-degree angle, and it's a bisector because I can see that these two pieces are the same. They are equidistant from the bisector. The next piece that we're going to talk about is our first theorem today. We have 4 different theorems we're going to look at. The first one is theorem 6.1, and it's talking about that perpendicular bisector that we just referenced. And in this picture, we can see that line CP is the perpendicular bisector of line segment AB. If that's true, if we're saying that this is a perpendicular bisector, then we can also say that CA is the same as CB. So if I know that this is a perpendicular bisector, it also lets me make some other assumptions here. And I know that those are the same, again, because C is equidistant from this endpoint A, which is also equidistant from this endpoint B. Okay. The opposite of that then is theorem 2, which is the converse of 6.1, which just flips it backwards. So it's saying that if DA and DB are the same, so that's these guys right here, it's saying if those are the same, then D lies on the perpendicular bisector. So they did this on purpose. They didn't extend the line. I could extend the line to see that this lies on the perpendicular bisector, but sometimes they just don't extend it, but it is lying within that perpendicular bisector. So if they say these are the same, then I know that this lies, that point D lies within that perpendicular bisector. So a quick example of those, so you can kind of see what this might look like on your assignment, is I can see here I have a perpendicular bisector. I know it's perpendicular because of the 90-degree, and I know it's a bisector because these two are the same. Because I have a perpendicular bisector, remember the theorem states that this guy and this guy should be the same. So if this is 8, then I know that would also be 8. In contrast to that, the converse, if I can see again that these two are the same, they're both 10, and I can see that this is the perpendicular bisector, then I know that if this is 4, then that has to be 4 as well. Our last 2 theorems talk this time about bisecting angles. And this one says that if ray AD bisects angle BAC, so here's angle BAC, and here is ray AD, it's bisecting it, which is what these little guys mean, these little arcs, saying that this angle and this angle are equal, they're the same. And BD is perpendicular to AB. So this guy right here is saying that this is perpendicular, if this is a 90-degree angle, and if over here this is a 90-degree angle, then I can say that BD is the same as DC, which is talking about this and this right here. It's saying that these two would be the same. So if this ray bisects this angle, meaning that these two angles are the same, and if this little line segment right here and this little line segment right here are perpendicular, then I can say that these two are equal. So of course the converse of that just comes backwards. So in the last theorem, it just says the opposite of that. If I have perpendicular to both and these two pieces are both equal, then I know this is a bisector. It just flips that theorem backwards, which is what converse is talking about. So an example of what that looks like are these two here. So again, I can see that this is perpendicular, this is perpendicular, and these two are equal. These two here are the same. So I know that this becomes a bisector. And since it's a bisector, if this is 42 degrees, then I would know that that is 42 degrees. And in contrast to that, again, I can see here, I already have a perpendicular bisector. I know this, or excuse me, I have an angle bisector. I know this because I see these two marked the same. So because these two are the same, and because this little guy is perpendicular, and this little guy is perpendicular to here, to these outside rays, then I know that these two pieces are equal. If they're equal, then I know, whoops, that I can solve that equation. So if I subtract 5x, I would get x. And if I add 5, so here's what x would be. If I replace that, 5 times 5 is 25. If I replace that, that would be 30 minus 5, and I get 25, which is what I should get, right? I need to make sure that these are the same, that they are equal.